Have you ever gone about your day normally and started to think, why does stuff do stuff? And then go back to doing whatever? Who hasn't? Well, don't worry, because today I'm going to explain why stuff does stuff. More specifically, we'll learn about Newton's 3 laws of motion. What are the 3 laws? To explain each of them, I'm going to be using the help of my favorite show, The Office. Now, let's get into Newton's 3 laws of motion. The first law states that all objects with a net force of 0 will remain at rest or continue to move with a constant velocity unless acted upon by an external force. Let's take a look at this clip.
Dwight, you do not learn, do you? For a threat to be credible, you have... No, you didn't. I'm sick of you and your...
Man, he's really in Twinkletown now.
Here we have Stanley on the floor, unconscious. Let's take a closer look at what's really happening. He is exerting a force on the floor through the force of gravity. The floor is exerting the same magnitude of force back at him, causing the net force to be 0, therefore causing no acceleration. He will never start to move unless another force acts on him. Let's take a look at another clip. Let's imagine Michael threw a slice of bread while deep into outer space, far, far away from our galaxy. What would happen? Would the bread fly out a few meters and come to a stop? No. Since outer space does not contain an atmosphere, there is no air resistance, friction, or gravity to slow it down. The bread would continue forever into space at a constant velocity unless something were to exert a force on it, causing it to accelerate either faster or slower. Let's look at Newton's second law of motion. The force required to accelerate a mass with an acceleration in the direction of the applied force is equal to the product of the mass and acceleration. That's a lot of words. More simply, the mass and acceleration of an object is directly proportional to the net forces acting on it. We can use the equation net force equals mass times acceleration. Let's look at some of the applications of this law.
Oh, good! I'll be your first customer!
You're hardly my first.
That's what she said! That is a $200 plasma screen TV you just killed! Good luck paying me back on your $0 a year salary plus benefits paid!
Here, Jan is throwing a Dundie at Michael's plasma TV. The amount of force she uses is proportional to the acceleration of the Dundie. If she were to use less force to throw it, the Dundie would accelerate slower. If she uses more force to throw it, the Dundie will accelerate faster. If the Dundie were to increase in mass, the amount of force needed to accelerate at the same magnitude would increase, and vice versa. There's one more law to examine, Newton's third law. This law states that when object A comes into contact with object B will exert the same magnitude of force in the opposite direction back onto object A. That was a lot of words. Let's take a look. Here Michael has a basketball. He drops it on the ground. Notice how the ball bounces back up. This is because the ground exerts the same amount of force back at the ball.
Stanley! What?
If Stanley uses more force to push the ball at the ground will exert the same force back and the ball will accelerate up faster. Now that we've examined each law, let's summarize. Newton's first law states that an object at rest will stay that way or continue to travel at a constant velocity unless an outside force acts on it. Newton's second law states that the net force of an object equals its mass times acceleration. The third law states that an action will cause a reaction equal in magnitude and opposite in direction. Don't forget to sub to my YouTube channel for more science and school-related content. See you next time. Bye!